video is to introduce and explain how to use the Optical Budget Calculator spreadsheet. Optigo Networks provides this simple spreadsheet to verify that an Optigo Connect Spectra fiber design meets the insertion loss requirements. That is, that the optical attenuation to all edge switches falls within the accepted range. One of the powers of Optigo Connect Spectra is the ability to connect several passive fiber splitters to create a low-cost and scalable large network, whether that's for wide buildings like shopping centers or tall buildings like office towers. Because different types of passive splitters can be stacked and daisy-chained, it is important to ensure that the overall passive optical network will fit within the allowed range of insertion loss. Before we look at the Optical Budget Calculator spreadsheet, here are the basics of passive optical splitters. Just like how water hose splitters will redirect water into multiple streams, passive optical splitters do the same thing with light. That is, light sent down one input will be split into multiple outputs, in this case, fiber strands. Now, insertion loss, also known as attenuation, is typically measured in decibel or dB. For example, a symmetrical 1:2 splitter will divide the downstream light into two equal parts. In terms of unit of intensity, this is a 3 dB attenuation. Optigo Networks provides many different types of passive splitters, including 1:2 symmetric splitters and 1:2 asymmetric splitters, and they size up to 1:32. For a complete list of splitters, please see the ONSYX datasheet available on our website or through your distributor. Multiple splitters can be interconnected with couplers, like this one, to create large passive optical networks. In Optigo Connect Spectra systems, the insertion loss to all edge switches must be within the range of 10 dB and 28 dB. For more details on why there's a minimum and a maximum attenuation, please see the article in our support portal, linked in the description below. Note that for simplicity, if you don't want to worry about the details of calculating insertion losses, Optigo Networks provides templates called shopping lists. These shopping lists are predefined designs for high-rise buildings and wide buildings with a complete list of materials. These shopping lists are available from your distributor or Optigo Networks sales rep. Okay, let's look at the fields in this spreadsheet and then we'll use some examples to better understand how to use it. In the main section, each row is independent and represents a composition of splitters and couplers between an ONSS8 aggregation switch and an edge switch. Here's the list of splitters and the corresponding insertion loss values below. You can see that these asymmetric splitters have different attenuation values depending on which output is used. For more details, please see the splitter datasheet. Now, for the rows that are to be manipulated. The first three columns are for information purposes only and are not used in calculations. They are there for your use. A switch ID, the type of switch you'll be using, for example, an ONS C810P, and a field to document the location where the switch will be installed. On the far right is the calculated insertion loss for each switch based on the path composition. You should have one row for every edge switch. This final number must be within the range of 10 dB to 26 dB. Note that we support insertion loss up to 28 dB, but we strongly recommend keeping to a maximum of 26 dB to account for variations. The middle part is the composition of the path. That is, what splitters and couplers are along the path to the edge switch. You count how many times the path cuts through a splitter or coupler on its way from the aggregation switch to the edge switch. Take this for example. To get from the ONSS8 to switch 10, the light goes through the trunk path of 7 asymmetric 1:2 splitters with 595 split, before hitting 2 asymmetric 1:2 splitters with 1090 split, and going out the branch of a third asymmetric 1:2 splitter with 1090 split. It helps to map out a diagram of your building and count the connections between the aggregation switch to the edge switch that way, as a reference for entering data into the budget calculator spreadsheet. Okay, let's pretend we have a building like this shopping center. Let's say we need 4 switches in 4 locations of each wing for a total of 16 switches. The ONSS8 aggregation switch is to be located in the control room here. Let's say that after looking at conduits, we decide to connect the 4 switches in each wing through a 1:4, then add a 5th 1:4 splitter to connect the 4 wings to the center. Finally, connect the center splitter back to the MDF or control room. Now, let's go to the spreadsheet. We know that we're using 1:4 splitters throughout the network, so we'll only be focusing on this column. And we know that from the ONSS8 to the edge switch, the network path will pass through 2 splitters in each location. There are also couplers that connect the splitters to one another heading into each wing of the shopping center. We'll include these couplers in our count of objects in the network path. Once we enter all this data in, we end up with a total insertion loss of 14 across the board. This is perfect because it is between that minimum maximum of 10 dB to 26 dB. Let's take another example, this time a 15-floor high-rise. First, we'll start with the aggregation switch, an ONSS8 in the control room here. We know that we want to install an edge switch on every floor, so we'll need 15 switches. And we'll use passive optical splitters to connect from the ONSS8 to every edge switch in the building, splitting off at each floor. Because this time we have one long line of switches to connect, we'll have to use some specific splitters to manage our insertion loss. On the first 7 switches, we'll use ONS YPS 2A05 LR splitters. These splitters are asymmetric, with 595 split sending most of the light up the line of splitters, hence asymmetric. On the next 6 switches, we will use the ONS YPS 2A10 LR splitters. These asymmetric splitters have a 1090 split, still sending most of the light up the line of splitters. Finally, we arrive at the last splitter where we'll use an ONS YPS 2 to send an equal distribution of light to the final 2 switches. Let's take a look at the spreadsheet. The splitters with asymmetric split have 2 columns that need to be taken into account. Let's start with the ONS YPS 2A05 LRs. The 13.1 dB insertion loss is the half of the splitter that connects directly to the switch. The 0.3 dB insertion loss is the part that sends more light up to the next switch and splitter on and on up the building. We count this up as we go through 1, 2, 3, 4, 5, 6, and 7 splitters passing light down this line. That 7 will remain the rest of the way down the spreadsheet because the light will always pass through 7 asymmetric 595 splitters with 0.3 insertion loss. The ONS YPS 2A10 LRs are 1 to 2 asymmetric splitters that also send more light out one split than the other. This time, however, it's a 1090 split, sending a little more light directly to the switch and a little less light up the line of splitters. We count this similarly to how we did before. This time, the 10 dB loss is the line directly to the switch, and the 0.5 dB loss is the split sending light up the building. We'll count this up as we go through 1, 2, 3, 4, 5, and 6 splitters. Just as before, the 6 will remain the rest of the way down the spreadsheet because the light will continue to pass through 7 ONS YPS 2A05 LR splitters and 6 ONS YPS 2A10 LR splitters. Finally, we arrive at the top of the building where we'll have a simple 1 to 2 splitter, this time with equal split for the final 2 switches. We'll also add the couplers in our count of objects as they connect the splitters to one another. We end up with total insertion losses that range between the floors, but all fall within that required minimum maximum that we specified before. We hope this was helpful and that you now have a clearer understanding of how passive optical networking works. Of course, if you have any questions and need help budgeting your network, don't hesitate to reach out to your distributor, your Optigo sales rep, or to email us at sales@optigo.net.